Yesterday, you worked on adding and subtracting polynomials. Today, we're going to work on multiplying polynomials. Remember, there are monomials and polynomials. A monomial is the product of a number and variables, something like 3x squared y. Just multiplying numbers and variables. A polynomial is the sum or difference of monomials. So for example, you could take that 3x squared y and add it to another monomial, 2x. That becomes a polynomial, more than one term. We always want to put our polynomials in the correct order. It's just kind of like straightening up your room. You want to make sure everything is in its correct place. And we call this standard form. When we put a polynomial in standard form, the terms are written in descending order by degree. For example, in this polynomial, we have third degree term first, then a second degree. This one doesn't have any exponent, which remember it means that it's a first degree, x to the first. This one doesn't have an x at all. So we call that 0 degree because it's like x to the 0, which is always a 1. So it goes from the highest down to the lowest, 3, 2, 1, 0. That puts it in the correct order. Every polynomial has a leading coefficient. A leading coefficient is simply the first number that's multiplied times a variable when you put it into standard form. So in this case, the leading coefficient is 5. It's just the number, no x with it. The degree of the polynomial is the highest degree of any term. So in this case, the highest degree was that 3. No other exponents were higher. So that's what we call the degree of our polynomial, third degree. And how many terms does it have? Each monomial is a term. So 5x to the third is a term, 8x squared is a term, 3x to the first is a term, 17 is a term. So this one has 4 terms. Notice each term is being added or subtracted together. So I'd like you to practice the next 2 problems. Put it in standard form, tell me what's the leading coefficient, the degree of the polynomial, and the number of terms. Now let's look at multiplying polynomials. Notice in this first one, it's a monomial times a monomial, one term times one term. So we're going to use the rules of exponents. If we multiply, we add the exponents. So this is x to the 4th power. I'll let you try the second one. Let's look at the third one. We have 3y squared times negative 3y. So we're going to multiply the 3 times the negative 3, which gives me negative 9. And we're going to multiply the y squared times the y. Adding the exponents, that is y to the third. So your answer there is just negative 9 y to the third. That's the correct way to do that problem. One of the common mistakes that I see students make is trying to distribute in a problem like this. They'll take 3 times negative 3 and say, well, that's a negative 9. And then 3 times y is a 3y. Then they'll do the y squared times the negative 3, which is a negative 3y squared. And then they'll do the y squared times the y, which is a y to the third. However, we do not distribute if there is no addition or subtraction in the parentheses. Notice inside the parentheses here, there's a negative 3y, but it's not being subtracted from something else. And there is nothing added or subtracted between the 3 and the y. So we do not distribute. Now in number 4, we do have addition in the parentheses, so we will distribute. We're going to take that 2x and multiply it times the x squared, the first term. That would give me 2x to the third, because remember that's x to the first, add the exponents. Then I'm going to take that 2x and multiply it times the positive 4. 2 times a positive 4 is a positive 8, so I'm going to put plus x, 8x. 2 times 4 gives me the 8, and I have that x still that I'm multiplying. And that's it. I cannot combine those. I'll let you try number 5. Let's look at number 6. Notice here, again, I have a monomial on the outside and is multiplied times a polynomial. So again, I'm just going to distribute times e to each term in the parentheses. 3x to the first times x to the third is 3x to the fourth. 3x, here I'm multiplying times negative 8x squared. That sign before the term goes with it. 3 times a negative 8 is negative 24. And then x to the third, add the exponents. Now I'm going to go to the next term, 3x times a positive 2x. 3 times 2 is positive 6. X times x is x squared. And then I have my last term, 3x times positive 4. 3 times 4 is 12. And I still have that x that I multiplied it by. Notice it's already in standard form. I'm going from the highest exponent down to the lowest. 4, 3, 2, 1. So I don't have to change my order at all. You guys try number 7 and number 8. Let's look at number 9. Now here it's a little different because it's 2 terms in the first parentheses and 2 terms in the second parentheses. We call that a binomial times a binomial. We're still going to just distribute. I'm going to start with the first term here and multiply it times both terms in the second parentheses. X times x is x squared. Since they both have that 1 as the exponent, adding those I get x squared. And x times a positive 4 is positive 4x. Then I'm going to go to the 3. It's a positive 3 times x is plus 3x, and a positive 3 times a positive 4 is a positive 12. Always check to see if you can combine any of your terms. In this case, these two combine together. 4x plus 3x is 7x, just adding the coefficients. And then I'm just going to bring everything else down. X squared plus 7x plus 12 is my final answer. Let's look at number 10 now. It's a little bit different because I'm subtracting in the parentheses, but we're going to do the same thing. We're going to multiply that x times both terms in the second parentheses. X times x is x squared. X times negative 7, use the sign that goes before the term. X times negative 7 is negative 7x. Then I'm going to take the negative 5. Negative 5 times the x is negative 5x, and negative 5 times negative 7 becomes a positive 35. Look at what you can combine. Negative 7x minus 5x is a negative 12x, and bring everything else down. X squared comes down, and the 35 comes down to give me that polynomial as my final answer. Let you try 11 and 12. Let's look at 13 together. Again, I'm multiplying a binomial times a binomial, so I'm going to take that 4x times both terms. 4x times x is 4x squared. 4x times a negative 3, use that minus with the 3. I'd multiply the 4 times the negative 3, and that's a negative 12. But I'm also multiplying times x, so I get negative 12x. Now we're going to work with the 5. It's a positive 5 times the x is a plus 5x. And a positive 5 times a negative 3 is a negative 15. Look at what you can combine. Negative 12x plus 5x. That would be negative 7x. Bring everything else down. 4x squared comes down and the minus 15 comes down to give me 4x squared minus 7x minus 15. You try the last 3 and then turn it in when you're done.